We need to find the average and RMS values of this periodic waveform, and then we need to determine what real power would be absorbed by a 100 ohm resistor if this voltage was applied to it. So to find the average value of any function, if it's periodic, you just need to get one period, so you need to look and see where it repeats. And so we have one period from 0 to 2. And the average value, I always think of average value as integral over interval. So it's going to be the integral from 0 to 2 of our function f of, or v of t, because it's voltage, v of t over our interval, which is 2 minus 0. Alright, so of course this is volts, so the average value will be in volts. So this over 2 minus 0 part, that's just going to be 1/2. And then if we look at our integral, we can see we've got two functions here, one from 0 to 1 and one from 1 to 2. So it'll be the integral from 0 to 1 of 1 minus e to the minus 2t dt plus the integral from 1 to 2 of e to the minus 2t minus 1 minus e to the minus 2 dt. Alright, so now we just have to remember how to integrate. This will be 1/2, and the integral of 1 is just t. The integral of e to the minus 2t is minus e to the minus 2t over negative 2. And this will be evaluated from 0 to 1. Plus the integral of, so I'm going to rewrite this over here as e to the minus 2t plus 2. So the integral of that will be e to the minus 2t plus 2 over negative 2. Now just to double check that, let me see if I differentiate that back, is that what I get? So the derivative of e to the minus 2t plus 2, the derivative of that is e to the minus 2t plus 2 times, the chain rule would say times the derivative of minus 2t plus 2, so times minus 2. And so then if I divide that by minus 2, yes, I get back what I started with. Minus, now e to the minus 2t, that's just a constant. So the integral of that will be e to the minus 2t, e to the minus 2 times t. And that's evaluated from 1 to 2. Alright, so then that becomes 1/2 times 1 minus, and that'll be plus, e to the negative 2 over 2 minus, now I'll plug in 0, 0 plus e to the 0 over 2 plus, now I'll plug in 2, so that gives me 0 e to the 0 over negative 2 minus 2e to the negative 2 minus, now I plug in 1, oh no, when I plugged in 2, minus 2 times 2 is minus 4, plus 2 is negative 2. But when I plug in 1, I get 0. Minus e to the minus 2. Or minus 1/2. So 1 plus 1/2 e to the minus 2 minus e to the 0 is 1, so that's minus 1/2, plus negative 1/2 e to the minus 2 minus 2e to the minus 2 minus negative 1/2, so it'll be plus 1/2 plus e to the negative 2 Wonder how many mistakes I've made so far. Equals minus 1/2. So let's see. 1/2 minus 1/2. Oh no, that's not that. 1/2 is. So minus 1/2 plus 1/2. Those cancel. I have a 1 here. 1/2 e to the minus 2 minus 1/2 e to the minus 2. Those cancel. And I get minus 2 e to the negative 2 plus e to the negative 2. That's minus e to the negative 2. And I get seem to have a sign error. Yes, there's a sign error. I don't know where this plus, that minus sign came from. So it's 1/2 1 minus e to the minus 2. And then if we get that, I thought I had my calculator open. So 0.5 0.5 times 1 minus e to the negative 2. Uh, 0.432 volts. Now, if I wanted to check this, integral from 0 to 1 of 1 minus e to the negative 2 x plus the integral from 1 to 2 of e to the minus 2 open parentheses x minus 1 close parentheses minus e to the negative 2, and then divide that by 2, and yep, got the right answer. Okay, now we need to do the RMS, and the RMS value, you take the square root of 1 over the period times the integral from 0 to the end of the period of x squared dt. So our interval is still going to be from 0 to 2, and we will have the integral from 0 to 1 of 1 minus e to the minus 2t squared dt plus the integral from 1 to 2 of e to the minus 2 t minus 1 minus e to the minus 2 squared dt. And then I will take this is 1/2 times all of that, and then I'll take the square root of all of that. I'm going to pause for a minute. Alright, so I squared 1 minus e to the minus 2t. Just remember, when you multiply, you add exponents. So e to the minus 2t times e to the minus 2t is e to the minus 4t. And you can check and see if you get the same thing I get. Now I will integrate. Okay, so when I integrate, I do the same thing that I did on the problem before. And I get these values, and now I will plug in. Alright, so I think I might have left that 1/2 out right there before, but then when you integrate, you plug in 1, you get these values, plug in 0, you get these values, and then for the second interval, you plug in 2, and you plug in 1, and then you just do all of the arithmetic, and so you check your numbers here, and when you do all that, you do get .5136, and these would be volts, and this would also be volts, so that would be our answer. That would be the root mean square value. And if you have any questions when you're doing the math, just send me an email. I just didn't want to bore you with my doing the math and the inevitable mistakes that I was going to make, and catch them. Okay, and then the last part was what real power would be absorbed by a 100 ohm resistor if this voltage was applied to it. Well, in this instance, our voltage is real. The resistor is just 100 ohms. It's also real, and so there's no complex power at all. It's just real power. So the power is just IV. Power is and if we are looking for a purely resistive load, which is what we have here, our average real power is going to be our RMS voltage squared over R. So our average power here, our real power, is our RMS, so 0.5136 V squared over our resistance, which is 100 ohms. Which is 0.002637 watts.